part of an experience made possible by the Ocean Discovery Institute.
A pair of earthquakes struck Baja California this morning, and people across San Diego County felt the impact of them.
In this video, we journey beneath the waves to unveil a stunning secret, a gigantic rift opening in the seafloor off Baja California that has left marine researchers and scientists utterly shocked. What began as a routine academic expedition to update seafloor data quickly evolved into one of the most surprising and captivating scientific stories of recent times. Nearly a mile beneath the Pacific's restless surface, something is stirring, an undersea volcano known for its activity and mysteries.
New here at 5, there's a large underwater volcano off the coast of California, and scientists think it could erupt soon. But don't worry, they say there's no risk of a tsunami.
Showing signs it could erupt by the end of this year. The changes it drives stand to reshape not only the local seascape, but could have implications for the broader Pacific coast as well. Beneath the surging currents and far removed from the busy shores, the team monitoring the region never expected what they were about to find. Their mission was simple: update maps, double-check long-term readings, and refine our understanding of the hidden ocean world just west of Baja California. Instead, they stumbled upon a sprawling fissure, a rift so wide and unexpected that it has sparked new scientific debates, urgent meetings among geologists, and both awe and concern within the research community. The central question echoing among experts is as vast as the rift itself. What does the sudden emergence of such a gigantic fissure truly mean? Could it be a sign of an imminent volcanic eruption, a harbinger of seismic shifts, or even the beginning of wider geological changes deep beneath Earth's surface? What new secrets, from ancient mineral-rich vents to unique marine life, might be lurking in this newly exposed chasm at the edge of the continental shelf? The more scientists uncover, the less certain many answers seem. Are we witnessing the early formation of a future island, or merely the opening of a deep and unpredictable geological event? The day the deep spoke back, a drone's shocking discovery. It started routinely, a research vessel, a diverse team of oceanographers and geologists, and a collection of underwater drones and sensor arrays. The Pacific waters off Baja California have long attracted attention for their underwater canyons, geothermal systems, and rich biodiversity enduring even in crushing darkness. On this occasion, the mission's objective was clear-cut: chart subtle shifts in the seafloor, document gradual topographic changes, and investigate patterns hinting at tectonic drift or potential volcanic activity. Yet, early in the mission, the expedition would shift from an academic task to a global headline. As remotely operated drones sank into the gloom, their onboard sonar instruments suddenly recorded unexpected readings. A gentle rise in the seafloor gave way to a jagged line that seemed to extend beyond the reach of the monitors. At first, the researchers thought it might be a technical error, but as the live feed clarified, the truth emerged. This was no glitch, but a significant geological feature in the world itself. The first images were haunting. Billowing clouds of sediment drifted from the edge of a freshly exposed chasm, mimicking an enormous release of undersea breath. The rift seemed to swallow the drone's searchlights, cutting off visibility. As more passes were made, the scale of the anomaly became clearer. Vertical cliff faces, streaks of unfamiliar mineral deposits, and hydrothermal fluid vents pulsing with rising emissions. The data suggested the fissure wasn't static, but actually growing, with regular rockfalls and rumblings triggering the submersible's most sensitive sensors. Was this a dramatic underwater landslide, or the early movement of something much bigger, closely linked to the region's volcanic and tectonic forces? Tectonic plates grind and overlap in this part of the world, a core element of the volatile Ring of Fire. But a rift of this size, and with such rapid development, was unheard of on this section of the continental margin. Why here and why now? Was it connected to a recorded uptick in micro-earthquake activity off Baja's coast in recent months? Or was it operating on its own unpredictable timeline? These questions took on new urgency as evidence mounted. A volcano's wake-up call, the threat of eruption. Once news of the rift's discovery spread, attention turned to another major factor, the presence of an active undersea volcano nearly a mile deep, close to the same region. This volcano has long attracted scientific interest for its unusual seismic and magnetic activity, and had previously been regarded as relatively stable, generating occasional minor tremors, but not direct hazards. However, over the recent season, seismometers monitoring the volcano had recorded increased activity. Now, with the widening rift in close proximity, every sensor and researcher focused on this ancient seamount. Thermal images revealed heat plumes radiating from the volcano's summit, showing as bright streaks cutting through the cold, deep water. Sampled water near the rift showed elevated levels of dissolved minerals, a potential sign of superheated volcanic fluids rising through the crust. Geochemists on board compared the chemical signatures with those documented in seamounts shortly before past eruptions elsewhere in the Pacific. Drone footage captured surreal volcanic landscapes. Spires of newly formed pillow lava glistened near the fissure's edges, suggesting recent and possibly ongoing eruptions of molten rock. Occasionally, faint reddish glows reflected off submersible cameras, hinting at high temperatures and dynamic processes beneath the surface. In essence, the volcano was not dormant. Its renewed activity appeared closely linked in time, if not directly in cause, to the emergence of the rift. With these findings, researchers found themselves racing against time. While there is no certainty on the timing or scale of an eruption, the possibility of this volcano erupting by the end of the year has now become a central working hypothesis in local risk analyses. If a major eruption occurred at such depth, it could have repercussions for sea life, disrupt fisheries, and pose potential risks for human infrastructure along the Baja Peninsula. But would the rift help by venting pressure, or would it funnel forces upward, hastening a dramatic event? These are questions that will only be answered in the coming weeks and months as monitoring continues. Daily, the research team debated the latest seismic readings, cross-checked records of previous eruptions, and ran model projections for various outcomes. Never before, by all accounts, had they seen so large and dynamic a shift begin before their eyes. Was the Earth stirring beneath our feet, or was this merely a prelude to deeper, slower changes we're only beginning to understand? Mapping the abyss, when a simple mission turns extraordinary. Until this discovery, many stretches of the deeper Pacific floor off Baja California remained scientific blank spots, charted in part by sonar and old cruise logs, but never comprehensively explored. Academic teams would revisit only occasionally to adjust navigational charts, calibrate instruments, and look for significant anomalies. This mission started as another of these necessary surveys, but will now be referenced far into the future. The expedition's approach was careful and thorough. Multiple drones and AUVs, seafloor sensors, as well as water and sediment samples for laboratory analysis. At first, the results were unremarkable, expected minor shifts in submarine ridges and the usual pockets of unexpected biodiversity. Yet all these surprises paled in comparison to the moment the first deep rift data came in. Upon receiving the initial readings, the team quickly escalated their analysis, communicating with partner institutions and relevant government agencies. Drones were redirected to focus on the rift, mapping the widening void in increasing detail. After many dives, it became clear this was no small crack, but a massive canyon. The fissure cut a jagged crescent, some segments dropping more than 100 meters straight down. The surrounding sediment was visibly fresh and disturbed, slowly pouring deeper every hour. Sonar mapping added to the scale of the revelation. The fissure was not a single gap, but a branching system. Some fractures spanned kilometers across, others dropped straight down, forming high, vertical walls. At several sites, Sensors recorded spikes in dissolved gas, lending more credibility to the theory of intense volcanic and tectonic activity at depth. Researchers compared the growing rift to a new Grand Canyon of the Pacific, still taking shape and still very much alive. The discovery transformed a routine mapping cruise into an international collaboration. Data from overhead satellites, distant seismographs, and legacy ship logs suddenly became critical for context and understanding. Through all of this, the rift itself continued to evolve, at times inching wider, at times rumbling with seismic bursts felt as vibrations aboard the research vessel. With the world beneath their feet literally splitting open, the researchers faced new questions about how to document and predict this event. Was this the beginning of a process that could last centuries, or an eruption that could happen in days? The unfolding saga has required not just science, but also rethinking how humans study change at a planetary scale. A world rewired, rethinking plate boundaries and deep-sea hazards. It sometimes takes a dramatic event to challenge everyday assumptions about Earth's deep processes. For years, scientific consensus held that the waters off Baja California, though tectonically active, were less prone to rapid transformation than other parts of the Pacific's Ring of Fire. Local earthquakes and scars documented ancient upheaval, but today's models foresaw slow, long-term evolution. The gaping rift and the renewed volcanic activity upended these expectations. As data poured in, seismologists and geophysicists worked overtime to correlate earthquake records with sonar mapping. They began to form new theories. Perhaps this branching rift was symptomatic of more significant changes in Pacific and North American plate boundaries, a reminder that the planet's bones are alive with slow and sometimes sudden movement. This has implications far beyond the world of geology. If plate boundaries in this region are more dynamic than previously thought, the risks of earthquakes and tsunamis may be higher than prior risk models suggested. Scientists debated whether the rift might act as a release valve, venting energy from the crust and potentially preventing larger disasters. Or, conversely, was it building up new stresses with the threat of future catastrophic events? No definitive answers are yet available, and the open-ended nature of the current data has driven the scientific community into heated debate. While the risk remains to be precisely determined, ongoing readings from seafloor instruments continue to detect subtle deformation, microscopic cracks radiating outward, perhaps foreshadowing future movements. In a worst-case scenario, such shifts could trigger underwater landslides, dangerous waves, or even regional tsunamis. For those who depend on these waters, the risk is no longer purely theoretical. The nature of the volcano's future activity remains an open question. If it erupts through or near the rift, will the event simply alter the seafloor, or might it temporarily disrupt marine ecosystems and nearby communities? Could the morphological changes encourage the formation of new geological features, or might they add to known hazards in the region? For researchers and coastal inhabitants alike, this is no longer a distant academic question. Each passing day brings more uncertainty about how to prepare for what might come next. Life on the edge, ecosystems of the rift. Even as scientists focused intently on the rift's risks, they could not ignore its ecological wonders. Along the newly torn fissure, high-resolution cameras documented an unexpected burst of life. On the exposed rock faces, strange crabs with mineral-streaked shells maneuvered between unstable boulders. Pale anemones colonized new overhang, harvesting nutrients funneled by the volcanic vents. Among drifting sediments, ghostly eels slithered into fresh cracks, perhaps among the very first to adapt to the rift's rapidly changing environment. Water samples revealed clouds of iridescent minerals and gases. Microbiologists on the mission found communities of extremophile bacteria thriving along the hottest, newest edges, species previously known only from other isolated hydrothermal vents or not seen before at all. These microbes, feeding on sulfur or iron, may hold clues to the adaptability of life in dynamic, hostile environments. The rift's vents, with their unpredictable flows of heat and mineral-laden water, could be acting as crucibles for new evolutionary developments. Every new dive yielded glimpses of invertebrates, sponges, and possibly new fish species exploring and colonizing the evolving habitat. The scene, half alien, half primordial, reminded scientists that where the planet remakes itself, life tends to follow. The looming question is how these newfound ecosystems would fare if the volcano were to erupt or the rift continue growing at its current pace. Some species may be wiped away in a burst of volcanic heat or chemical change. Others might recolonize the altered terrain, adapting again and forming the basis for an even more unusual living system. In some ways, the rift has become a real-time laboratory for observing the interplay of catastrophe and rebirth in Earth's biosphere. For some on the expedition, the experience evoked the notion of a Galapagos of the deep, a site where evolution and geology intersect in ways rarely witnessed directly. For others, it's a reminder of how fragile even the most resilient forms of life remain in the face of profound planetary change. Each day and every meter, the rift widens, adds a new layer to the unfolding narrative of Earth's living and changing oceans. Danger and awe, preparing for the unknown. As weeks passed, the research vessel stationed above the rift evolved into both a floating laboratory and a high-alert command post. Communication lines hummed continuously as scientists around the world checked in for updates, requesting new drone images, the latest seismic charts, and expert assessments for the possibility of increased hazard. Despite the calm surface of the Pacific above them, those aboard remained acutely conscious of the tumult unfolding below. Frequent, minor tremors generated concern among the crew and researchers. Would the rift widen further, potentially venting new gases or generating underwater shockwaves? Could the volcano erupt soon? And if so, how much warning would they get? Preparations for the unknown became an urgent priority. The expedition leaders developed emergency protocols, rehearsed alert notifications, and established direct lines for quickly sharing information with coastal authorities should danger appear imminent. Automated sensors transmitted real-time data to international scientific networks, monitoring for critical changes in temperature, gas emissions, and seismic oscillations. Yet, even amidst the tension, a sense of wonder pervaded life on board. Scientists who are often reserved found themselves overtaken by the thrill of directly witnessing an event of this magnitude. "We may be witnessing a moment of planetary transformation," remarked one geologist in a remote briefing. "This isn't just observation. By being here and documenting it, we're part of the history Earth is writing even now." Out along the rift, the drone teams maintained their tireless surveys. As of the latest updates, the fissure's growth remained steady, but not accelerating beyond critical thresholds. The volcano, while more active than before, had not yet shown signs of a full eruption, but the data's unpredictable swings kept everyone cautious. Each new blip reviewed for indications that the story might take an even more dramatic turn. Scientists pondered what else lay inside the rift, now mapped more comprehensively, but still far from entirely revealed. Would it lead to deeper hidden caverns, or twist into layers of Earth previously sealed away for millennia? What clues in the structure of rock or the arrangement of ancient minerals might still be hidden, waiting for more persistent probing? The answers remain elusive, a vivid demonstration that every discovery opens up more questions. When the sea opens, wonders and warnings. In the ever-shifting balance between excitement and apprehension, the reality of the rift has settled in among the scientific community and the wider public. The chance to observe Earth's forces at work, to witness perhaps the beginnings of a volcanic eruption or the birth of a new landmass, has inspired awe and nervous fascination in equal measure. Equally significant are the revelations about the deep ocean's ecosystems and the likely need to revise long-standing models of tectonic activity. This chapter closes where it began, with curiosity, humility, and more than a little uncertainty. What has the formation of this gigantic rift off Baja California truly revealed about our planet and about ourselves, share your thoughts and questions. Because when the sea itself opens, the future is written in the dynamic, shifting cracks beneath our feet.